Hi, everybody. I know a lot of you, but for those of you who don't know me, my name's B5. In normal human space, my name's Brendan, but most of you know me on the internet, so I'm B5 there. I work at a company called Number Zero. We work on a project called Iroh that I'm going to tell you about today. Yeah, I think today's going to be fun because we've been working on Iroh for a little while, and we've kind of been on a bit of a soul-searching, trying to understand what we've been making, and we've come to some conclusions, and I'm very excited to share those conclusions with you today. And so the title of this talk is taking IPFS to millions of new places. And I think the millions is a little bit like, really? Millions? Like okay, how are we gonna do that? And I genuinely mean it. I think millions is a reasonable and achievable goal, and specifically new with some of this work that we've been doing in the last little while. And to get to millions of new places, we need some problem that we're gonna solve that isn't currently solved in a meaningful enough way. And the one that we're really focused on now is sync. This basic idea that synchronization is a really gnarly problem. Those of you who are big fans of CRDT research, you always hear this line, for all nodes that have received the same set of messages, they're in the same state. This have received the same set of messages is a sync problem, right? For those of you who you work in content addressing, there's this really big thing that you run into where you get a hash, you take that hash and you send it somewhere, and then somebody needs to change that hash because it's an application and the state's going to change. And now you need to transmit that hash again. And so everybody who's built on top of IPFS has encountered this sync problem in a very material and meaningful way. Secretly, it's just a distributed systems problem. And we think that attacking this and making a major inroad on this is a great way to take IPFS to a lot of different places. And so after a lot of soul searching, we've come to the conclusion that Iroh is really about being able to sync anywhere and really increasing the portability of synchronization. And so, what does that even mean? Some of you may know this gentleman. A lot of these ideas happen to involve his input. To get into some specifics, this is kind of how we think about Iroh. It's inside of this isn't your classic can't pick two, you can't have all three. You can have all three of these things. They're independent concepts. They kind of sit on a spectrum. And so Iroh sits somewhere between a database, a network of computers, and an object store. And so to put some other technologies in this same space, you've got your SQLites up in the corner that maybe they do a little bit of object store type stuff, but they're really not for networking. The whole idea with SQLite is you embed it. And then IPFS has this wonderful sort of midpoint between being a network and an object store, not a ton of databasey stuff. Your classic operating system file system, that is an object store under the hood. You can't really query that in a meaningful way. But for us, we're trying to sort of hit this sweet spot right in the middle to provide a new thing that isn't covered by these existing technologies. And so we take this database networked object store concept, and we've actually layered on these pieces of Iroh that fit together to make the technology itself. We call those documents, connections, and blobs. And so for those, we call those the layers of Iroh. Today, we're going to spend a lot of time talking about documents. That's the core synchronization thing. Blobs are the thing that are the most like IPFS if you know it today. Blobs are content address data. But in Iroh parlance, a blob is just opaque bytes. You do not get to know really what's inside of it. Then below that are connections, right? And this is just an emphasis on direct connections between stuff. If you put that in a nice, pretty picture diagram, this is kind of how it looks. You've got a document in the middle. This is how we're going to do all of the synchronization. You've got connections between devices, right? And then that document is going to link to blobs. I'm not going to go into deep detail on the structure of documents and the data model and stuff on that. We'll cover that in the workshop. If you want to hear more about that, that's after this. But the thing that I want to sort of I just want to cut to the chase and give you a demo of what I mean by sync everywhere. And hopefully that'll help drive a lot of this home and make it a little more palatable. And so, do I have everything set up? This is a good question. All right, so I'm going to show you some stuff. And by new places and far places, I'm going to start in a fun new place on my phone. And so you won't be able to see this, and I just got too close to this. This is fun. But what has just happened is my phone has created a document, and it is now here. And that document's ID is 3UP. Cool. And when it did that, it also sent it to Iroh Cloud, or Iroh.network, which is our cloud backing service. Cool. So I'm going to jump into that document. I'm going to look at my connections. I have a whole bunch of connections, one of which is direct, and you'll immediately realize that you won't immediately realize, I will tell you that this server is in the United States, and we are currently in Istanbul, and my latency is 146 milliseconds. That is going to be relevant. That's not a great ping, but it's still worth looking at. So I'm going to take this thing. This thing has a photo taker hooked up to it. And so like, I'm not really selfie game, but we're going to do that. And that shows up there. And we can see my stupid face. Hey, cool. And like, I think the bit that's fun is like, sorry, camera people, I'm moving. I won't move around. Sorry, I can't move around. But it's like kind of quick, right? And great, we can sync. These two devices are connected. Oh my God, go away. We've got phone to Iroh.network. Cool. This is a cloud connection. This isn't hard, right? So let's do something more complicated. Let's bring in, okay, now I have to do a little bit of juggling. Host 2002, I think? Yes, cool. What I'm gonna do now is I'm gonna share a ticket. A ticket is our way of getting stuff, and I'm gonna bypass this write warning for reasons that you'll see in a second. I'm gonna go over here, and I'm gonna say, hey, yeah, let's replicate this to IPFS. And what you're immediately gonna see is this thing joins the document, sees everything in it, syncs that, pulls that data, puts it on IPFS, and tells us about it with these hashes. So I can now go this, localhost 8080, IPFS. Most of you, hopefully some of you have played with this before. And we can see my stupid face again, yay. And again, the thing that's fun here is it's synced. So it shows up and then it replicates it, right? And this is what we mean by lots of new places. We've got this incredible new paradigm when you can suddenly do synchronization in a meaningful way. Now we have this new kind of substrate that lets us do this compute in the loop. And the bit that's really fun was the hard part. Right now, my phone and my laptop have a much better ping than the cloud network. And we actually have a solid direct connection between the two of them, right? And so that's the tough bit. And we've focused really hard on getting an incredible, consistent connection between devices as we go. And this is what we in the peer-to-peer and direct networking space really care about, right? And so I think from there, it'd be fun to try and stress this a little more. Anybody got a laptop? Yeah. All right, cool. I'm gonna need you to, I'm hearing zippers. It's a very, cool. This is, I need you to do this. So you're gonna, if you go to iroh.computer/docs/install, it'll give you a copy pastable version of this. And then I need you to join a Discord. Sorry, because that's how I'm gonna get you a ticket. And what you're gonna do is you're gonna, where you saw ticket, yeah, follow these things and copy, where you see the enver for ticket, you're gonna have to copy paste the thing from the Discord, if somebody can get that. If you have some other way of transmitting that. The install is, you could copy, well, you can't copy and paste because you could manually type that, or you can do iroh.computer/docs/install. This is gonna be fun, we'll see if this works out. Rudiger, you already have this on there. Can you check to make sure that that works? Oh, hey everybody, what's up? Oh, I'm sorry. You are all looking at this screen. I need to give you this access. My bad, my bad. Yeah, we're gonna stress test this thing live. We're gonna see how it works. Particularly my phone. And we'll talk about why I'm very confident doing this in a second. But I would love an audible gasp if you actually manage to sync anything or get to the doc keys. So doc keys will let you see it, and then doc watch will do to see if we can actually do something fun. But anybody made it yet? Version 0.6 of Iroh? No, you need 0.10 or higher. Actually, not higher. 0.10 is the latest. You need 0.10. The ticket is in the Discord. So I pasted it here. I can paste it again. Boop. So you're going to do doc join, and this switch flag is going to just it will set the console to actually pay attention to that document in particular. I'm going to join myself. And actually, no, I can't because you guys need this pulled up. So you got it. We got a thumbs up. Okay. I'm going to take a photo, and we'll see if you get the new photo. I'm going to take a photo of this wonderful thing. I don't know what this is. Oh, the clicker. Yeah. Let's see if it's synced here. Nice. I heard an audible gasp. We've got some work happening. Cool. All right, I'm going to leave this up. I'm going to keep talking. Feel free to, does anybody need an extra couple of seconds with this up? Or feel free to play around. Yeah, Iroh start is the thing that turns on your local node. Thank you, everybody, for helping stress test this thing. I will take one more photo of how much time I have remaining, which is that much, and see if you can pull that guy up. But I think the bit that is, hopefully you can see the value here of sync, right? We have a bunch of new paradigms that emerge from this. We have this fun little replicator sitting in a loop. I can also like do stuff on the actual console. I can affect this from multiple parties. This one has a write key, so I can do hello world. And our little IPFS replicator will then dutifully copy hello world to IPFS, which is super useful, I guess. Maybe not useful, but hey, whatever. But keeping with this theme of like syncing anywhere, we have this all set up in a sense that gets us lots of languages and lots of access to a lot of different places. So currently Iroh ships in Python, Go, Rust, and Swift, and we're adding more as we go. And when we mean an SDK for this, we mean that Iroh actually can run natively in that runtime. So you can run pip install Iroh, and you will do Iroh new node, and you will have a node running in the process that is currently there. And the huge advantage of that is imagine yourself in remote machines, in Python scripts, in whatever. It is much faster and easier to bring Iroh into your process. And this is what we mean by sync anywhere. We can take it onto phones. We can take it into applications. We can take it into all these different spaces that makes this whole system far more useful because you can now start to bridge other technologies together, right? On top of that, we're demoing a little bit of this, which is this Iroh.network piece. And this for us is two things at once. One, it's a product. And two, it deals with the issue that you run into in peer-to-peer systems where people turn their phones or laptops off. And so this is a high availability system that lets you push and pull to. It is a full SaaS service. It has a free tier that I'm using today to show you this thing, and it has a paid tier that you can use to get more concurrent connections, bigger storage, and all the like. But most importantly, it's not required. You don't need Iroh.network to use Iroh at all. And there's lots of use cases that really show up when you really focus the whole thing around connections like this. In particular, like this notion of sneaker nets, which is kind of an abuse of the term because sneaker nets usually are actually just USB keys. But we at Number Zero all the time are using Iroh to debug Iroh. We generate a lot of logging information and have to send logs to each other. And it's just this like giant pain. And like a bunch of you are now have Iroh on your machines, thankfully. And so like I need to get you the slides for this talk. And so at the end of this, I will just put this in and paste a ticket for you to grab this whole thing and be able to pull the slides for that talk using Iroh. And so we use this all the time. And it's like a really classic, simple use case when you have these fast direct connections. Next bit I think that is also quite fun are gateways. And this idea that like we see from IPFS land. And Rudy, did you send me that thing? Awesome. So this is an example of a gateway in Iroh parlance. And so what we're doing here, hopefully this one works. Did you give me a new ticket, Rudiger? Oh, cool. Do I have a node running? Oh, let's find out. I have to restart my gateway, don't I? Oh, no. Cargo run. Yeah. What? Oh, I'm in the wrong place. There it is. A lot of stuff flying around today. But see if that'll figure itself out. Oh, this would have been my fun to demo. There we go. Cool. Gateways. This is actually not the sync side. This is just a straight blob of 5 gigs of content that I am not caching on my machine. This is currently fetching from Rudiger's machine, which is right there in the room. And we're streaming that from his machine to mine. And I can seek, I can play. Yeah, totally. Get the full experience of what are we watching? Some Internet Archive piece. Something we checked to make sure that we had something that was public domain before doing this. But yes, a distinguished French scientist who was having. But like the joy of this is that this is just the thing that's distinct about what you're probably used to from IPFS space is the ticket bit that we were showing actually includes dialing information. And the thing that was being shared, as you can see, this URL has shifted. This is a piece of a collection. And so this is very similar to the way you think of like a UnixFS directory. We're actually seeking into the whole hash and then getting a specific bit out of it. But we're also incrementally verifying this as it is being transferred. And so this is doing the whole trick of like if somebody had constructed a false version of this incredibly enthralling public domain film, we would know about it as it was streaming immediately. We verify it both on send and receive, which is like a very nice property where if you have data corruption on either end of the wire, you'll know about it. Another wonderful use case. And then the one that we really care about, which is apps, right? Like the ability to like build apps on top of this is kind of the whole point. And so here I'm just showing you a document being joined so that you can actually just kind of use Iroh.network as a data model explorer. And so on the right, this thing is just using a document to store its information or the state of the app. And this could easily be synced across a whole bunch of people, right? You have all of anybody joins that document, they're gonna have this wonderful live synced thing. But you also have all of those tricks that we showed at the beginning of this where we were ingesting to IPFS, but that's a generic solution. You can write software that comes in and, oh, cool, somebody uploads photos. You can do the photo resizing in band as part of the process and dump the results of that back into the same document, right? When you have sync as a fundamental substrate, you get all of these new tricks that show up. And we think that's what really drives this whole system into brand new territory, right? And so by millions of new places, like just in the process of this conversation using my phone, I created like 25 IPFS hashes and synced them and sent them both to IPFS and to Iroh, right? And this is what we mean by sync. I think the sort of substrate of being able to sync anywhere is like it's this incredibly valuable, useful addition to things. The fun thing about Iroh is like we're not trying to replace your Postgres database. We're not telling you to rip out whatever you're currently using. Strap it on top and use it to glue between stuff and open up new things that you couldn't do before. And I think that's the really exciting thing. When you have sync, all of a sudden you can say, oh, I'm going to pull this data from that system and this data from that system, harmonize them and do something interesting with it. I'm going to do heterogeneous compute where different nodes in the network will have different roles depending on their strengths and weaknesses, right? And so really you can sync anywhere. And I'm doing this mainly just to get a dig, but you can send him wherever you want. And the idea of having this magical capability to just any node declares that everybody who's interested gets the thing that they have just published instantly, completes the sort of read-write cycle. And if you think about where we've been in IPFS land and in content address data for a long time, we've kind of been, in my mind, we've been in read-only mode for a long time. I add to IPFS, I get a hash, and then someone consumes it, and then you run into this problem of, okay, now what? How do we change it? And once you get the right side and you have synchronization in the loop, everything, it doesn't get a little faster, it gets a lot faster. You can make a lot more data a lot quicker. And I think that's the really exciting bit. And so that's what we're up to. This is open source. A bunch of you joined our Discord. That's great. You have a thing that you can use. You should totally sign up for the free Iroh computer thing. You should check out our docs and start coming and hacking on this with us. It is early-ish days. A lot of this stuff is actually pretty solid at this point. Definitely lots to do, but we're pretty pumped. Like, I think this is like some groundbreaking shit over here. And so, yeah, thanks. That's kind of the whole spiel. I can take questions if anybody has any.
Thanks, Brenton. I'm just curious about the JavaScript support you have for this. Do you have any front-end libraries available that may also need support?
Totally. So on the JavaScript side, you mean the browser, or do you mean Node? Do you mean Deno? Do you mean what's your all of it? Do you want me to answer it all?
Any.
Yeah.
If any support, if it's Deno, that's great.
Yeah. So like obviously, not obviously, but just, oh man, it's still playing. Good job. This is JavaScript, and it's talking to Iroh data. This is happening over a WebSocket and an HTTP API. And so, not great, but I fully intend to write and would love to work with folks on writing a JavaScript library that, for now, at least just consumes the HTTP API and then go a little deeper. If you're in Deno or Node land, we can do far more interesting stuff. And so that's where the core of this is all written in Rust. So WebAssembly becomes a very interesting and exciting avenue. And so the thing that we've focused on really hard for this whole project is getting the API to be completely consistent. And so when you do docnew and you see this, you can see an example of how to do docnew in the console, and then in Python, and then in Go. And the idea here is these concepts should be consistent and the API should be singular, right? And so the question, my answer to your question is let's go implement the API. Yeah. Cool. Ghazan, do you have a question?
Yeah, I was wondering sorry, I'm loud, I realize. The docs that you're syncing is like a flat list of key values, essentially?
Yeah, and so we should get into that. I can briefly speak to that because it's a little more complex than just key value. It is a set of key, which is bytes, not UTF-8 strings, so you can do hashes in there or whatever you want in there. We can thank Rudiger for that insistence. The size of the content, modification timestamp, this is literally a wall clock timestamp, and the author. And you'll notice a special thing about the author. Oh, and the value is always a hash, right? And so that is the full schema of a document, and that's locked in the protocol, basically. The thing that really matters is if I tried to set photo as a prefix, you'll see I get all of these yellow because I am currently author this, which is kind of hard to see. And these entries were written by some other author. And so we are in a shared namespace, and think of it as a table with like different keys. I can't actually overwrite that. I can overwrite my own stuff, right? And so I actually wrote hello into here earlier. So if I go...
And if you have two different computers, they're both you, I assume. Does that mean individual computer can only overwrite things that it edit or across your computers?
Yeah, so we deeply encourage folks to use, we call these authors. And so you can have not just multiple authors you can have as many authors on a node as you want. And so that it's kind of like identities, but it's sort of more a substrate for that. And so you can think of it more as like a per device identifier. So my author key on my phone does not move to here. And so that's how we distinguish folks.
I guess what I'm getting at, like, how do you deal with conflicts? I assume that you might have a concurrent writes.
Yes. So
somehow you need to resolve it.
The idea here is it's kind of drop dead simple. It's just wall clock timestamps. And the timestamps are consistent to the individual authors because the authors are local. And so you can do last write or rins combinations of these things, but sometimes you just don't deconflict them. Like we can have multiple hello keys and values, which is a little weird and a little, you have to kind of do some getting used to. You can also just write a query that says, give me the latest write of hello and just suffer from the idea that you're going to have clock skew. And so if two people write really close in time, but it's intentionally messy because that's the nature of the thing, right? But you have the tools you need to disambiguate. Question two, yeah.
Semi-related to that, is there any notion of access control? And I mean, how can I create a document that nobody else has access to, even if they have the...
Hi, thank you.
Yeah, sorry, yeah.
Super confused. So we kind of have access control, sort of. We have read and write, right? So I shared read access with all of you. I didn't give you write access, but it is, yeah, I know. It is whole document. Right now, you have no way of cutting up the subspace. This is all based on a actual protocol called Willow, actually, which we are an implementation of. And it has a spec that I think wonderfully marinates between the world of UCANs and OCAP, and there's work to be done here. But we at least have the baseline. I can just share a read key and a write key. We plan to get more sophisticated on that. It's really hard to get this right, and we got to figure, getting the boundary on this is going to be something we do with users.
So they are loud. So I remember earlier this year, maybe it's last year, there was some excitement because what you were doing with Iroh was kind of separating from the whole bundle of IPFS sort of protocols and systems. And I never quite managed to wrap my head around which bits still connect and which bits are different and how that actually affects how you might, use IPFS and this together. So
totally.
Would you
I can elaborate on that.
Yeah,
Absolutely.
give the 10,000 foot kind
Yeah.
of view.
So these are the three layers I want you to think about conceptually. You would call connections libp2p in IPFS land. You would call blobs IPFS in IPFS land. Documents, I don't think that there's a proper allegory for that. That maybe, like MFS, I'm not going to, yeah, maybe. Connections for us is completely different. We have done a total ground up implementation of our networking stack. It is not compatible with libp2p. It is written on top of Quick and the notion of something called a magic socket, which is a set of technologies pioneered by Tailscale. The reason for us doing that, this whole demo hinges on direct connections. My phone and my laptop must be able to connect to each other. It's not a probabilistic thing, it's these devices. And so we optimize for that solution. Blobs is easily the most compatible layer. You can have any hash function you want in Iroh as long as it's Blake 3. Yeah, and so but that section, when we did, to speak to the compatibility, the way that I was actually doing the IPFS translation layer, you can see some of this where the hashes on here are actually the same. It's actually just ingesting the hash and doing an equivalency where we punch it into Kubo and get out the other side. If that thing is less than a meg, the hashes will actually be equal and like completely the same. And we have a couple of users who have like their systems, just all of their blocks are below a megabyte, often because you're doing IPLD work. And so you just get fully equal systems. When you start doing photos and arbitrary size data, then things are going to be different. But so we lose compatibility there. We lose compatibility at the, so there's like, I think the blobs plus connections, there's a really strong influence of IPFS. There's some bridging work that we can do. And part of the point behind this demo is to show that bridging work is like trivial, right? Like I could just leave this running for folks and have the IPFS bridge rocking, right? On top of that, all of these, I should also mention, all of these records are signed by the author. So you have an actual signed attestation that this was what it says. Sorry, I've got a minute 30, so let's go down. Yeah.
Can you talk a little bit about, so each node also has an HTTP server which serves as some kind of like a local bridge, or no? Okay.
No HTTP server on the node's stock. The gateway that we showed is an example that you can run separately. Okay. And so this, and that's in our Iroh examples repo, but like this thing that was streaming, that is, not streaming the movie anymore. Oh, still streaming the movie, yes. Is just like a bolt-on. And this isn't actually, this bit is just the blobs and connections layer. Okay. It doesn't have any documents. So, yeah. So HTTP bridging, I think, is pretty trivial, and we have some great examples of it, but yeah. Yeah, we're at time.
So Iroh is like there's Iroh binary, but it's also meant to be used as a library very easily. So if you need something where you have an Iroh node which combines the HTTP gateway, you can just take the two things, build it in a single Rust crate, and you're done. It's very simple to plug together. But by default, we don't want it, because if you're on a phone, for example, you might not want an HTTP gateway, and nobody's going to need it, and it's wasteful to have it. And like having it and then disabling it, that's also not great. So it is just an external component.
Thank you so much, everybody. Really appreciate your time.